Hello everybody, and thank you for joining me today in this talk about Hugo and how it parses Markdown files. Let me first introduce myself. I'm Duccio Gasparri. I am a student at the University of Bologna, and I'm quite new to Hugo. I started using Hugo because I had my notes in LaTeX and in Markdown files. So I came across Hugo as an easy solution to publish and update them, and I got interested in it. What I've learned and what I'm presenting today comes mainly from reverse engineering Hugo. If you have any question, feel free to tweet me even during the presentation and I'll try to answer. So, why reverse engineering Hugo? As I said, I'm no expert. I've been using Hugo for a couple of months now, but Hugo doesn't have internal links. Also called wiki links, that are the kind of links with double square brackets that are used in other wiki software like MediaWiki or Wikipedia. I wanted to implement this feature because I'm keeping my files, I'm updating my files with Obsidian, and Obsidian makes huge use of those internal links. But in order to do so, I had to understand how it was processing Markdown pages at the very low level. At first, I tried the direct approach. I opened the source files and read the code. But it didn't work out because Hugo code is too obfuscated. Some functions are injected or chosen at runtime, and the structure is not really clear and consequential. Pieces are inside other pieces, and in the end, it wasn't an easy task to understand what was Hugo doing at any certain moment. So I went back and did some reverse engineering. How was Hugo reverse engineering? Well, a big part was done in the old-fashioned way, putting a lot of print line around the code and see at which point in the execution that line was written on the console or in a file stream, just the same, just to get a sense of how the structure was and who was calling who. But then I understood that the code is too big. Hugo code library is definitely too big for that. So I had to revert back to a more systematic way, and I started dumping stack traces, and I just did a lot of with regular expressions. I found all the functions inside the code, and I started to trace dump to a file for later review. So what did I learn? How is it Hugo inside? Well, I ignored the file structure, the templates, and so on, at least for now, because it was enough of a big task to understand how the Markdown was parsed. So I'll save it for later. And I focused on what was of interest to me, specifically on the way Hugo parses and handles Markdown files. Hugo has three main blocks to process Markdown files: the Lexer, the Parser and Goldmark. Those three blocks combined together transform a Markdown file into a HTML file for publishing. Now let's look at each block individually, what it does, and more important, what it doesn't. Goldmark is a native Markdown processor written by Yusuke Inuzuka. I hope I'm pronouncing it correctly. And it is an independent project from Hugo. It's fully compliant with Common Mark 0.3, and it can process the main Markdown items such as headings, bold, lists, links, so on. But it cannot process other items such as templates, shortcodes, or links. Goldmark has no idea of the internal structure of the website, so it cannot really resolve a link inside of our website. So there is a need for an outer layer of pre-processing and post-processing of the files to handle those items that are ignored by Goldmark. And here comes the parser. So the pre-processing is done by the parser. The parser is really the first step of the whole process. It has two jobs. First, it invokes the Lexer. And second, it receives the pinch content as digested by the Lexer, that is, a chunk of pieces of front matter, shortcodes, links, markdown or plain text, and so on, and handles them. Specifically, it handles front matter, summary dividers, shortcodes, and emojis. The plain text or the standard markdown are not processed by the parser. They are just left for Goldmark. And then there is the Lexer. The function of the Lexer is to find hooks and try to divide the page in chunks according to its functions, so that the parser can process each chunk accordingly. The Lexer tried to separate front matter, shortcode, and emojis from the rest of the markdown and of the code. So to recap, the Lexer divides the page in chunks of front matter, shortcodes, plain markdown, and so on. The parser takes the list of chunks from the Lexer and processes them. But it doesn't touch the plain markdown, that is just left to Goldmark. And in the end, there is Goldmark that processes the remaining markdown in the page, headings, italic, underlines, and creates the final HTML file. Let's now look at the low level. The parser is contained in the page parser package, and it is called by the function new page from content node. The parser is responsible for creating, feeding, and running the Lexer. It is worth of note that the Lexer state, so-called Lexer state, is set by the parser, as we will see later. Specifically, it is set to the function lex intersection. And this is relevant. The Lexer is based on function chosen at runtime, and they are chosen according to the content of the file. When I was reading the source code, it was really hard for me to understand what the Lexer was doing and when it started, because the run function is just 4 lines and it just iterates through these states. But here it gives the entry point for all the subsequent states. So this is a rather important starting point for the Lexer. Once the Lexer has finished, the chunks that are emojis, shortcodes, front matter, are passed through to the function map content for result. The Lexer at the low level is called by the parseBytes function. The function newPageLexer sets the initial state of the Lexer. It is called a state, but it is indeed a function for parsing the content given. And the next state is set by the previous state. This setup is non-trivial because any Lexer function not only has to process its part of the content, for example, front matter, but it must also decide which Lexer function should run next. In a sense, it must be aware of the available Lexer functions and make a decision on what to run next. There is no real separation of concerns, and when you try to understand Hugo's code, it's not so easy. That part is quite confusing. But the most important Lexer functions are lex intersection, which handles the front matter, the lex main section, that handles more or less everything else,
subdivided in sub-Lexer function, and the Lexdown, that is the exit point that interrupts the cycle. And then we have the Goldmark. The Goldmark is a third-party library, so it is not changed in Hugo. It is just imported along with some of its extensions, and it is instantiated at the very beginning during config loading. There is one instance that it never changes. It is provided to the code as an interface, a Markdown interface. This Markdown interface exposes the convert function. That is a function that takes the Markdown and returns the HTML. Nothing special here. So, to sum up, the function new page from content node, it's more or less the entry point, the starting point of everything, and it is responsible of calling the parser and then calling the Goldmark processor. The Lexer splits the page in chunks according to their content type, front matter, shortcodes, etc. And the parser takes each chunk that is not markup and processes it. Then the content is passed to the Goldmark processor for final markup parsing. What I presented here is just an overview of the huge code library of Hugo. You can find these slides and additional notes at that address shown. I will try to keep it updated with everything new I learn or everything new that I come across. And that's more or less ends my presentation. I hope you have enjoyed our time together, and if you have any question or want to follow up, feel free to tweet me or drop me an email. Thank you all for being here with me, and thank you for the HugoConf for hosting me, and I wish you all a good day. Bye.